In previous video, we have seen functional programming languages, its features, concepts, and also the origin of this functional programming languages. And we have seen that the Lambda calculus is the main origin of it originated, the functional programming languages, they originated from this Lambda calculus, which is considered to be as the model of the computation, church model of computation. So Lambda calculus, a syntax is given in which here E will be some expression, and it will be having the right hand side, it will be having three types of expressions. It can be either variables, or it can be any application, function application, or something like function creation. So we have seen in the previous video itself, like lambda, that notation means that it will be representing a parameter. Okay, so here in function creation, it is given like lambda x dot e, in which lambda x dot e will be called as the lambda abstraction, and e will be known as the lambda expression. And this lambda expression, it can be any unnamed functional value. So function creation will be in the form of lambda x dot e. So x will be considered as the formal argument, and e will be the functional body. So x will be a formal argument which is following after this notation lambda, and e will be some functional body. It will not be having any names and can have arguments. Then it can have variables. Expression can be having some variables or some function application. Then related to the function application, it uses a notation like e1 dot e2 or e1 e2. It will be combined together. It means that the application function e1 to the argument e2, to the actual argument e2. So this e1 will be the function which is giving an argument e2. To create a function in scheme, one evaluates a lambda. So we are learning this lambda calculus based on the scheme language. So lambda is a church model of computation, and how it is being done in the scheme language we will be going to learn. So we make use of a construct called as lambda of x. So this will be an argument to lambda, and this will be treated as the body of the executable body of the function. Okay, so this will be the argument and these will be the executable statement. So together it will be called as a lambda function. So what is the operation that is performed here? X will be given as an argument, and another form of expression is here given, like this star will be a function. It will be taking the arguments x and x, which means x into x. So these operations will be performed taking the input value of x. Okay, so x is the formal argument, and the next one, star xx, star indicates a star xx. Together we can call it as the body of the function. Body of the function, it will be used to perform some operation like multiplication operation, taking the two operands x and x. So these operands also will be passed in the form of arguments or parameters. So lambda expression does not give its function a name. So no function name will be given. So when we are giving, see this example, lambda of x star xx. So here we need to we need to consider the parenthesis in order to get the value or the result. So lambda of x star xx lambda of x, this is the argument, and star xx is the body of the function. So this lambda, it's being closed here. Next comes the 3. Lambda function is closed using this parenthesis, and next what is it is having a value 3. This value will be given as an argument, that is the actual argument to the lambda function. So this 3 will be given as an actual argument to x, and the body of the function will be like 3 into 3. After executing, you will be getting the value as 9. So lambda expression is a function itself which is nameless. So we can see the some examples related to this and how the values are being mapped. So here see lambda of x plus xx, and the value passed is 2. So in such case, what will be the output? 4. It will be taken as 4, which means 2 plus 2, 4. Next, lambda of x, body of the expression, body of the function, x plus 42. So actual argument is 23, which means 23 plus 42, you will be getting 65. Again, lambda, it is taking 2 arguments, x and y. Body of the function is plus x plus y. And the 2 actual arguments will be 23 and 42. So when actual argument is given, it performs the operation 23 plus 42 to get the result as 65. Then lambda x1, x2. Here the body of the function is a expression with the sub-expressions also. Which means here we are performing a multiplication operation of 2 expressions, x1 minus x2 and x1 minus x2. So the values that is given is 2 and minus 5. So when we are substituting the value for x1 and x2 as 2 and minus 5, what happens? The first, this expression, when performing the value 2 minus minus 5, that is 7. And here also you will be getting the result as 7. Then performing the multiplication operation, 7 into 7, you will be getting the result as 49. So this is a concept behind the lambda calculus, which is considered to be as the model of computation. Then scheme language, how it is being implemented in the scheme language. We are going to see the implementation of scheme language. So these much things we will be learning in this scheme language, and start how it is being developed. Who invented? It is invented by Guy Lewis Steele and Gerald J. Sussman. Emerged from MIT, originally called a schemer, and which is shortened to become scheme. The interpreter will be following a read, evaluate, write infinite loop. So it is read, value will be read, that is expression will be read and from the standard input, which is usually typed by the user. Then it evaluates the expression, and write means it will be printing the resulting value after evaluation. So the interpreter will be following this read, eval, print loop. In case of a scheme, okay. Then so if an expression is given like plus 3, 4 means the interpreter will be printing 7, which means 3 plus 4. And user types 7, the interpreter will also print 7. Then it will be using the Cambridge Polish notation, which is a variant of prefix notation. That is, operator will be there followed with the operands. So parenthesis indicates the function application. Parenthesis indicates the function application in which the first expression that is inside the left parenthesis, it will be indicating the function, and the remaining things will be considered to be as the arguments. So when a parenthesis is encountered, interpreter, in this case what it does, interpreter will be calling the plus function, passing the arguments 3 and 4. So then you will be getting the output as 7. In order to prevent the interpreter from evaluating any parenthesized expression, what you need to do, you need to insert a term like quote. You need to insert a term quote. So quote within parenthesis plus 3, 4. So it will not be evaluating the expression. Interpreter will not be evaluating the expression if it sees a quote. So the output will be plus 3, 4. So and a shorthand representation for the same statement can be written like this. So in this case also the output obtained will be like plus 3, 4. So in this here, a symbol here we are using, that is this imply symbol. So it means that it evaluates 2. So it is not a syntax of the scheme, and it will not be included in the code. It is just to see, it is just to understand that the statement will be evaluating and you will be getting what result. Then related to the different functions, as we have seen, plus that is parenthesis will be helping in determining the function. So within parenthesis, the first parameter will be taken as a function name, and the second and third or the later parameters will be considered as the arguments which will be used on the function given in the first. So most primitive functions or the basic arithmetic used for the basic arithmetic operations are plus, minus, star and slash. As you all know, can be used for add, subtract, multiply and divide. So if star is given as a function, that is the first argument, and it has no parameters, means it will be returning the value as 1. And if plus is given and no parameters is given, it returns the value as 0. So plus, it helps in, it does the addition of all the parameters together. Star also, it multiplies all the parameters together. In case of abstraction, the second parameter will be subtracted from the first. Second parameter will be subtracted from the first. So we can see the operation 5, 7, 8. Plus is the function. So what you will be doing? Add all the parameters. You will be getting the result as 20. Then in case of subtraction, subtract the parameters. You will be getting minus 1. Multiplication, multiply the parameters. You will be getting 21. And again subtraction. First you need to perform subtraction of first 2 parameters. You will be getting 8. Then 8 minus 2. You will be getting as 6. Next, this one, 20. First inner one will be evaluated. That is 12. Then minus 24 and 12. 24 minus 12, you will be getting 12. If plus is given with no parameters, means it will be returning as 0. And if star is given with no parameter, means it will be returning the value as 1. Next, related to the primitive functions, other primitive functions are ABS, SQRT, remainder, min and max, in which max will be returning the max is also a one function in which arguments 2, 3, from the arguments 2, 3, 4, it will be returning the maximum value, in this case 4. And if we are giving min means it will be returning the minimum value, that is 2. SQRT if you give and a value is given means square root of that value